Okay, limits AP calculus part 2, part 3. So problem 2. Here we said we did before in the previous video this one, which is the problem 1. We can substitute directly because we have 0 in the numerator and we end up with 0 as an answer. This one, problem 2, differs from problem 1 because we will have a minus in the denominator. So that's why we should do it in as two parts, because if we say its limit of x plus 2 over x minus 3 as x tends to 3 plus, we have 3 plus 2, 3 or 3 plus, no problem, because the same, it gives me 5 in the numerator. In the denominator, 3 plus minus 3. 3 plus is more than 3. So 3 plus minus 3 is 0 plus. So the answer is plus infinity. While limit as x of x plus 2 over x minus 3 as x tends to 3 minus, it's 3 plus 2 in the numerator. Also, we have no problem having 3 minus, because 3 plus 2 is 5, or 3 minus plus 2 is 5 over 3 minus minus 3. 3 minus is less than minus 3, so we end up with 0 minus, and that gives me negative infinity. Here, in this case, the limit does not exist, because right hand limit as x tends to 0 plus does not equal to the left hand limit. So the limit of x plus 2 over x minus 3 as x tends to 3 does not exist. Let's see in problem 3. Problem 3, if we divide it also into two limits, limit as x tends to 3 plus of x plus 2 over x minus 3 to the power 2 in the denominator, we end up with 3 plus 2 over 3 plus minus 3 to the power 2, which is 5 over 0 plus whatever the 0 in the denominator is, because we are squaring it. So we end up with infinity, and limit as x tends to 3 minus of x plus 2 over x minus 3 squared. Also, we end up with 5 over 0 plus, because we are squaring, so it will be equal to also plus infinity. This means plus infinity or infinity, this means the left-handed as x tends to 3 minus gives me the same as the right-handed. So the limit here is infinity. Limit of this one is infinity. The limit equal to infinity. Okay, if we substitute directly in problem 4, instead of x, its value, which is minus 4, what we will have? X squared minus 4 squared is 16. 16, yes, minus 4 squared is 16, plus 6 times minus 4, it's minus 24, plus 8 over minus 4 instead of x plus 4, right? Up will give me 0, 8 plus 16 is 24, minus 24, 0, and down 0, and this is undefined form. So that's why we should do what? We should say it's equal to the limit as x tends to minus 4. We should change the form. How? We can factorize the x squared plus 6x plus 8 by guess and check xx, or we can do it in another way. We will do it also in separate videos next time. And plus 8 is plus 2 times plus 4, so we end up with if we have to check, multiply the plus 4x and the plus 2x, the extremes and the means, it gives me plus 6x, which is in the middle, over x plus 4. Now we can simplify the x plus 4. What left is limit as x tends to minus 4 of only x plus 2. We substitute directly instead of x its value, and the answer is minus 2. The answer is minus 2. Problem 5. Problem 5, we did some rules about that because x tends to infinity. X approaches infinity. We can take only the 15x squared over 22x squared and simplify the x squared. So the answer will be 15 divided by 22. Problem 6, limit of 4x over tangent x as x approaches 0, which is equal limit as x approaches 0 of 4x. We always have to substitute instead of tangent x sine x over cosine x. So it will be limit as x approaches 0 of what? Of 4x over sine x, and this is 1 over cosine x. It's times limit of cosine x over as x approaches 0. Okay, now what is the limit of x over sine x as x approaches 0? This gives me 1, so it's 4 times 1 times cosine 0. Cosine 0 directly is 1, so the answer is 4. Okay, problem 7, it's 5 plus x, 5 plus h squared minus 25 over h as h tends to 0. And this is very important because in the next chapters we are going to see the derivative, and we are going to use this form to know the derivatives. So it's equal to limit as h tends to 0. We can expand 5 plus h squared, and we can factorize the whole thing in the numerator, which is a squared minus b squared. So it is 5 plus h minus 5, because 25 is 5 squared, right? This is 5 squared into 5 plus h plus 5. It's a minus b into a plus b over h, which is equal to limit as h tends to 0 of h into h plus 10 over h. We can simplify the h, which is equal limit of h plus 10 as h tends to 0. Substitute instead of h its value now, and it will be 0 plus 10, and it is 10. We can also simplify it as expand the numerator, which is identity, square of the first, 2 times the first times the second, square of the second, and minus 25 beside it. Minus 25 plus 25 we can cancel. Its limit, it's 0, 25 minus 25, as x tends to 0. H is in common, 10 plus h over h. We end up with the same answer, which is 10.